Okay, next, so let's see whether you remember a very special result about EX, which is no matter how you differentiate e to the power x, so it gives you its original result. So as a result, when you are integrating exe, so which means it's still ex. While you will see, I also ask you once again about over xe. So that's why it's minus 4 ln x plus c afterward. So it finishes, we finish example 5. After that, we have a kind of question in the exam paper very often, like example 6, where you have to differentiating expression first, dy dx. Afterward, you have to use the result of A to get the answer of B. So what does that mean? And let's see how we are going to do A first. So you see the expression is not simple because it's in fraction as well as including the square root sign. So, but by nature, the question is about quotient rule. But if you remember before that, you better turn those third form into rational index first. So now let's take a minute or even a few minutes to get the result of dy dx. So it will be a very big one, so leave you more space to write the answer. If you forget the result, so you bear in mind that so when you are having ddx of u over v, so it should be v square, a square at the bottom, keep one, differentiate the others, vu dash, then minus uv dash. So which means at the bottom you have x plus 1, then v kept x plus 1 to the power 1 over 2, minus x squared minus 1 keep unchanged in the second part. Now it comes to you differentiate u dash and v dash respectively. So the first one, you differentiate the u, so it gives you 2ac. The other part, including a chain rule, so you have to move down the power reduced by 1, and then differentiating x plus 1 gives you a 1. So here comes the result of dy dx. So of course you still need to simplify it, definitely. So you have 2xc, x plus 1, 1 over 2. Next you have minus 1 over 2, x plus 1, minus 1 over 2. And then x squared minus 1 afterward. So you still have a x plus 1 at the bottom. Now so it doesn't look like a very good answer, and then because so there's a 1 over 2 here, as well as it's power 1 over 2 but power minus 1 over 2 for x plus 1. So normally we will be doing this simplification like this, so which is I choose to take out this common factor, well, for scaling. So we try to take out the smaller one, called minus 1 over 2. As well as I want to, okay, so let's keep it here first. So 2x is still there. So what's the next one? Can you write it down carefully? So it should be x plus 1 because you take away minus 1 over 2. So after that, the next part will be minus 1 over 2. And then so you still have x squared minus 1. Now you see in the blue brackets, the expression is getting simpler somehow. Now we deal with 1 over 2. And then so again, we move it to the front. How about we skip a step to write like this? 1 over 2, if we put it in the front earlier. So if we keep 1 over 2 earlier, then next, so this one will disappear. And then this one will be changes to 4. So then, so you have 1 over 2, x plus 1 minus 1 over 2. Inside you should have 3x squared, 4x squared minus x squared, 4x plus, and then 4xc and plus 1. So divided by x plus 1 at the bottom. Okay, so these two can be put together, and I move it to the bottom. 1 over 2 move to the bottom as well. So that's why, so 2 move down, and then x plus 1 becomes 3 over 2. Well, for this one, you can try to use cross method to see whether there are any more simplifications onward. So you have plus 1 plus 1. Wow, that's really a simplification. So which is 3x plus 1 and then x plus 1 afterward. So which means x plus 1 can be further cancelled, and you have 3x plus 1 divided by 2, x plus 1 to the power 1 over 2. Similar thing can be found in example 7 and 8, so let's read them one by one as follows. So once again, you have to find dy dx first, followed by integrating with the result of a. So now let's take a look in part A first. Y would be xc tangent square xc, so which means it's about product rule, definitely. So in product rule, so you'll see, if you remember, differentiating uv is uv dash and then u dash v. So that's why dy dx gives you xc. Tangent square should be differentiated by chain rule, so it's 2 tangent x first, then differentiating tangent, it gives you secant square. Next part will be tangent square kept unchanged. Differentiating x, it gives you a 1. So finally, it's simply 2x tangent x secant square x, and then plus tangent square x afterward. Next, we come to part B. So note the word called hence. So that's why we must consider the expression one by one. You must consider the result in A. So you will see this expression x tangent x secant square x appear once in part A. So that's why I rewrite the expression like, so it's d, so how should I write? So you see it comes from dy dx minus tangent square, and then there's still a 1 over 2 removed. So the expression would be like this at first. Next, 1 over 2 should be taken away first, so for our convenience of doing integration. And then now let's see the following.